Hello everyone. So myself Sony Jenusha, working as an assistant professor in the Department of Electronics and Communication Engineering at Kamaraj College of Engineering and Technology. So today we are going to see the fundamental concepts of Boolean functions. So today I will be covering Boolean functions, sum of products and products of sum. So we will be seeing what is sum of product and how it is linked with min terms, and what is product of sum and how it is linked with max terms. Then we will see some examples for these two topics. So let's dive into the topic. So what is Boolean function? So Boolean function is the Boolean algebra deals with binary variables and logical operations. The Boolean function describes by an algebraic expression. So I have given an algebraic expression here, that is the f of 1 is equal to x plus y dash z. So here the Boolean expression is divided by the logic operation, that is OR. So similarly it has the binary variables like constant zeros and ones that are separated by symbols, that is logical symbols. So what is sum of product? So the logical sum of two or more logical product term is called sum of product. That is, the product terms are divided by the sum of logical operation, that is OR operation. So this is the example expression for sum of product, that is AB, that is product terms are separated using this OR. So this kind of expression is called as sum of product. So next we will see what is product of sum. So the product of sum is logical product of two or more logical sum term is called product of sum. So here I have given a example expression, that is f is equal to a plus b dot into, that is b plus c dot a plus c. Here the producted term, that is a and b, is odd and separated by the AND term. So this is the example expression for product of sum. So here we will be seeing, as I mentioned in the earlier, here we will be seeing what is min term and max term. So min term is a product term containing all the k variables of the function in either the complemented form or the uncomplemented form, is called the min terms. So here I have given a variable min terms, that is 2 variable min terms and 3 variable min terms. So for a decimal number 0, 1, 2, 3, the two input variables, that is 0, 0 as the input variable, then 0, 1 as an input variable, 1, 0 and 1, 1. So for this particular input we will getting the min term as the 0, here it is taken as complemented form, that is we will mention it as a bar. For 1 it is uncomplemented. So min term consists of the outputs as 1. So we will be calculating 1 in min terms. So 1 is in uncomplemented form and 0 is in complemented form. So simultaneously, if you see the table, truth table, you can understand the 0, 0 is mentioned as a bar, b bar in terms of min term. Similarly, for the 3 variable, we have 0, 0, 0 as input. So it is mentioned as a bar, b bar and c bar. So for the decimal number 1, that is 0, 0, 1 is mentioned as a bar, b bar, c. So simultaneously for 2, 0, 1, 0, that is 0 is mentioned as complemented form, a bar, b, c bar. 3, a bar, b, c. For 4, a, b bar, c. For 5, a, b bar, c. For 6, A, B, C bar, and for 7 A, B, C. So, this is the minterm expression for the following decimal as the inputs. So, next we will dive into what is maxterms. So, what is maxterm is the sum term containing all the k variables of the function in either complemented form or uncomplemented form is called as the maxterm. So, let us see the truth table for the two variables. Here, as I already said, 0 is considered as the output. So, here we will be taking 0 as A, that is uncomplemented form, and 1 as a complemented form. So, for 0, 0, that the maxterm will be A plus B. As I already said, it is sum of terms. So, it will be A plus B. For 0, 1, A plus B bar. For 1, 0, A bar plus B. For 1, 1, A bar plus B bar. So, simultaneously, if we move on to the 3 variable truth table, for the decimal number 0, 0, 0, we will be writing it as 0 A plus B plus C. For 0, 0, 1, we will be writing it as A plus B plus C bar. So, for 2, A plus B bar plus C. So, for the same procedure is followed till 7. For 7, we will be writing as A bar, B bar, A bar plus B bar plus C bar. So, this is the difference between the minterm and maxterm. So, for minterm, we will be writing the term as in product form. For maxterm, we will be writing it as sum form. So, now we will be seeing what is canonical sum of product expression. So, it is a logical sum of all the minterms derived from the rows of the truth table for which the value of the function is 1. So, let me give you a simple example. So, consider this is the same truth table as I have showed in previous slide. So, this is a question y is equal to summation of m. So, the minterm is denoted by the symbol summation of small m. The summation of small m into 1 comma 3, that is the decimal number 1 comma 3. So, this 1 comma 3 we have to write it in a expression form. So, how you will write it is y is equal to for the 1, for the particular 1 decimal number, the minterm expression is a bar dot b. So, we will be writing it as a bar dot b. For the 3, as you can see from the truth table, for 3 we will be writing the minterm expression as a b. So, as you all know, sum of product is divided by plus symbol. So, it is ORing the product. So, product terms are ORed here. So, a bar dot b plus a dot b. This is how you will write as the canonical form of sum of product. So, canonical form of sum of product I have given the 3 variable example. We have seen the 2 variable example previously. Now, we will be seeing 3 variable example. So, here the expression is y is equal to summation of m 2 comma 4 comma 5 comma 6 comma 7. So, for the particular given question, we have to write the expression. So, how you will write is, again we have to see the truth table. From the truth table, the 2, the decimal number 2 we have written as a bar b c bar. So, the a bar b c bar we have to write for 2. Then we have to divide it by adding the sum, that is OR symbol. Then for 4 it is a b bar c bar. So, a dot b bar dot c bar. Then for next 5 is a b bar c. Then for 6 is a b c bar. For 7 is a b c. So, summationing ORing all this term, we can get the expression for the given question. That is for 2 comma 4 comma 5 comma 6 comma 7 we have written the expression here. So, let us see an example problem. So, y is equal to, as I already said, we have stated the truth table. From the truth table we have analyzed and written the expression. So, in the examination point of view, we will be getting a questions like y is equal to summation of m 0 comma 5 comma 6. So, for the particular question, we will change it as a minterm, that is minterm 0, minterm 5, minterm 6. So, for minterm 0, it is for the decimal value is 0, 0, 0. So, minterm 5, the decimal value is 1, 0, 1 in binary form. For the decimal value 6, the binary form is 1, 1, 0. So, we have to write it in the expression form. So, as I already said, in the SOP, that is sum of product, we will be writing zeros as in the complemented form and 1 as uncomplemented form. So, that is what I have written here, that is 0, 0, 0 is a bar dot b bar dot c bar, then I have divided it by or in the terms, then a, b bar, c plus a, b, c bar. So, this is the first example. So, let us see the next example. So, how to change the expression? It is given in an expression form. We have to form in a standardized SOP. So, for standardized SOP, the given term is y is equal to a plus b. So, this a plus b, we have to see how many variables are there in the particular expression. So, there are two variables, that is a and b. So, here we have to, first step is to analyze the missing variables in each term. So, this particular term we are missing the b variable. In this particular term we are missing the a variable. So, the next step is we will be writing it as complemented form by ORing. So, or the complemented form of the missing variable, then we will be adding to the terms. So, here b variable is missing. So, we will write it as a dot b plus b bar. The next term a variable is missing. So, we will write it as a plus a bar. So, now we have to solve it. So, we have to expand the expression. So, how we will expand is a dot b plus a dot b bar plus b dot a. You can rearrange and write it as a b plus a bar b. So, this is the second step. For the third step, we will be omitting the repeated variables. So, as you can see, this a dot b is repeated twice. So, we will cancel it, omit once, and we will write the other expression, that is a dot b plus a dot b bar plus a bar dot b. So, for the particular expression, we have to write it in the minterm form. So, minterm form is, as I already said, a is mentioned as 1 and the complemented forms are mentioned as 0. So, 1, 1 is decimal number is 3. So, in this binary forms the decimal conversion is 2. So, this particular binary forms decimal number is 1. So, we will write it as summation of m is equal to summation of m praises 1, 2, 3. So, this is a final answer for the particular problem. So, the same procedure for the 3 variables also. We have to see what variables we have missed and we have to solve the, we have to add those missed variable in the sum form, that is c plus c bar, and we have to product it. Then we have to solve the expression and we have to expand the expression. After expanding, we have to omit the repeated terms. Then by omitting it, you have to write it in binary form. From binary form to minterms, from minterms to we have to write the result as summation of m into 3, 4, 5, 6, 7. So, this is a methodology we will be following for standardized canonical form of sum of product. So, the next is product of sum. So, what is canonical product of sum is the logical product of all the max terms derived from the rows of the truth table for which the values of the function is 0. It is called as a canonical form of product of sum. So, here I have given the 2 variable expression. The canonical forms are denoted as pi of capital M. So, it is denoted as pi of capital M. So, it is a crisscross version of SOP. So, as you can see from the truth table, here the decimal number is 0 and the binary form is 0, 0, and we have to write it as a plus b. So, 0 is in, we have to write it as a uncomplemented form. For ones, we have to write it as a complemented form. So, 0 is a bar plus b, 1 is a bar plus b bar. So, I have given an example here how to write. So, if the question is pi of capital M 0 comma 3. So, pi of M denotes the max term of the value. So, we have to write the max term of the values. So, max, how you will write for the particular decimal number 0, see the max term, it is A plus B. So, it is separated by, we have to write A plus B, then it is separated by dot operation. So, product form, then for 3 we have to write as A bar plus B bar. So, A bar plus B bar. So, this is the final answer for product of sum. So, for the same thing follows for 3 variables also. So, in 3 variables, as you can see, so the given question is pi of capital M 0 comma 3 comma 7. So, you have to analyze using the truth table in the initial stages. For truth table, the decimal number 0, we will be writing the max term as A plus B plus C, and for decimal number 3, we will be writing the max term as A plus B plus A plus B bar plus C bar. Then for 7, we will be writing as A bar plus B bar plus C bar. So, combining all this in dot operation, that is producting all these terms, we will get the output. So, first problem for canonical product of sum. So, as I already mentioned, the canonical for product of sums are denoted as capital M. So, capital M0, capital M2, capital M4, capital M7. So, for this particular thing, we have to write it as a binary form. So, for this 0 decimal number, the binary form of 0 is 0, 0, 0. Then it is separated by dot operation. Then binary form of 2 is 0, 1, 0. Then binary form of 4 is 1, 0, 0. The binary form of 7 is 1, 1, 1. So, for this particular thing, we have to write the max terms. For 0, 0, 0, the max term is A plus B plus C. Then 0, 1, 0, the max term is, it is separated by dot operation. Then A plus B bar, the one is, as I already said, we have to write it in a complemented form. The one is here in a complemented form. So, A plus B bar plus C dot, then for this A bar plus B plus C dot A bar plus B bar plus C. So, this is how we will expand and write the max terms. So, here we have given I have given the expression y is equal to A plus C bar dot A plus B bar dot B plus C. The same methodology what we followed for sum of product is followed here also. The first step is to find the missing literals. So, from each terms what literal is missing, we have to find it. So, here in this particular term, the B literal is missing. So, in this particular term, C literal is missing. So, in this particular term, A literal is missing. So, the second step for product of sum is, we have to product the missing literals in complemented and uncomplemented form, and we have to OR it. So, A plus C bar plus the missing literal B as written as B dot B bar. Here the missing literal C is written as C dot C bar. Here the missing literal A is written as A dot A bar. So, what we have to do is, the third step is to expand the expression. So, after expanding it, we will be getting the answer as follow. So, the fourth step is, after expandation, we have to see whether the terms are repeated or not. If the terms are repeated, we have to omit the particular term and write the answer. So, after omitting, we will be getting this answer. So, for this answer, we have to write it in binary form. So, the binary form for product of sum is, the uncomplemented form is 0 and the complemented forms are written as 1. That is 0, 0, 1 for this particular term and 0, 1, 1 for this particular term and 0, 1, 0 for this term and 0, 0, 0 for this term and 1, 0, 0 for this term. So, once we have written in a binary form, then we have to change it into digital form. That is, we have to write it in as M1, this is M3, that is 4 to 1, we can write based on the 4 to 1, you can refer the truth table in previous slide. So, for this particular binary form, we have to write it as M2, M0, M4. So, after that, we have to combine it, and for some product of sum, we will be denoting it as pi of capital M. So, pi of capital M 0, 1, 2, 3, 4 is the answer for canonical product of sum. So, you can take this exercise problem and you can solve it. If you have any doubt, you can ask in comment section. So, with this, thank you for patiently listening my lecture. Thank you.